In the last video, we worked out that T of n is equal to the sum from I equals 0 to n of O of 1 times 2 to the I. So in this video, we're just going to wrap up and finish this summation, or figuring out this summation. So the first thing we're going to do is we're going to pull out O of 1, since O of 1 is a constant, and that just leaves us with 2 to the I inside the summation. So to figure this out, we just recognize that this is a geometric formula which has a well-defined sum, which I guess you can look up, but might be useful to see the derivation here. We're gonna let S, the sum, be equal to this summation right here. Sum from I equals 0 to n of 2 to the I. So what is that? That's going to be 1 plus 2 plus, or you know what, I'm going to write this a different way. That's going to be 2 to the 0 plus 2 to the 1 plus 2 to the 2 plus dot 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 all the way down to 2 to the n. And now we're going to multiply S. We're going to multiply S by 2. So what is 2S? Well, 2S is just 2 multiplied by this whole summation. And if we multiply in this extra 2, so that's just 2 times 2 times this whole summation. Well, we factor in the 2 here. Well, that's just equal to 2 to the 1 plus 2 to the 2 plus 2 to the 3 all the way down to 2 to the n plus 1. What I did was I just multiplied this 2 into each of the factors, or each of the terms in this sum right here. And so the cool thing to notice is that when we subtract this by this, just about all of the numbers, or all of the terms, cancel out. So what I mean by that is take 2s minus s. Well, then that's just this minus this. You'll notice that when we do this summation minus this summation, all of these middle terms are going to cancel out. What we're just going to be left with is this minus this, which is 2 to the n plus 1, minus 2 to the 0, which is 1. And here on this side, on the left side, we're going to factor out an s, just be left with a 2 minus 1 here, equaling that. So we get S, our original sum that we were interested in, is just that divided by that, which is just 1, which means this cancels out. Right, this becomes a 1, and so we're just left with that. And so this summation is just O of 1 times this value right here, 2 to the n plus 1 minus 1, 2 to the n plus 1 minus 1. And if we were very detail oriented, we would notice that this would be the same as 2 times 2 to the n minus O of 1. I'm just factoring in this O of 1 here. We notice that this is a constant, so we cancel that out. This is also a constant, we can cancel that out. So this becomes an O of 2 to the n. So that's our final answer. Our runtime for the Fibonacci problem is O of 2 to the n. This is exponential time. Exponential time. And this, for any sort of algorithm, is a pretty bad thing to have, something you don't want. You generally want some sort of polynomial time. In other words, n to the power of something, not something to the power of n. Right, and this will be the motivation for dynamic programming that you might see in algorithms.